5-5 day 2 pre-lesson. Let's get this thing going. Again, 5-5 day 1, I emphasize the phrase composing functions, composition of functions. Don't panic. Remember, that's kind of like stuff to kind of cloud your vision a little bit. It's pretty simple. At the end of the day, don't let that phrase throw you. So let's get started. This is another problem where we're composing functions, but we don't need to make it difficult. It says if f of x equals x squared, so there's a function, and g of x equals x plus 1, there's another one. We're going to blend them together. That's the composition of functions sort of definition in my mind, okay? But this is how you're going to blend them together. This is actually your math problem. And I want you to notice this right here is on the inside. So that's what we're going to do first. There's a song by Phil Collins called Inside Out. And I always play that in class just to kind of plant that idea. So look it up on YouTube, play it, and it'll pound this idea in your head. But we're inside out. Kind of like PEMDAS, you know, P, you work inside the parentheses and then you work out. Very similar here. So we're going to find g of 3. Well, remember, g of x is kind of our generic term. So this is a way of just saying, let x equal 3. But put it into the function defined by g. I know that's difficult sounding, but it's just this. So we're going to put that 3 in for that x. We get 3 plus 1, which is 4. Now watch this. So my answer to this is 4. So what I'm going to do now is I'm going to take that out. I just found what it equals. It equals 4. And now I'm going to plug 4 in to the function defined by f. So the second thing I need to do is find f of 4. Well, find the function defined by f. There it is. Put 4 in for x. So I go 4 squared, and I get 16. Now, when students are doing this, it's kind of like, well, what's my answer? Is it both this and this? Well, it's the final thing you get. This was like a stepping stone that allowed you to get to your final step, and there it is. So that would be your final answer. Now, you notice I kind of twisted things on you. So now, what are we going to do? Well, we're going to start with this now. So we're going to go, all right, find f of 3. Well, we find the function defined by f, right here, x squared. So we're going to go 3 squared. We know that's 9. So we put a 9 in there. Now we have a second problem to do. We've got to put 9 into the function defined by g, which is right here. So we're going to go g of 9, put it right in there. 9 plus 1, 10. The final thing you get is your answer. Before I erase this and go on to the next problem, this problem right here, the original problem, sometimes you might see it like this. They're the same thing. It's really not a multiplication symbol. It's a little tiny open circle, but you just have to know when you see this, it's the same thing as this. Notice g is on the inside, so you can just think of it like that. It's the same thing, so don't panic when you see it. What is the rule for composition? See that? Sounds difficult, but it's not. I give you permission to kind of ignore it, but it is what you're doing. So we look at the problem, we think, wait, that looks a little different. Well, don't panic. What's on the inside? G. So you should think, aha, it's the same thing as this. And here's another thing. This is the same thing as this. So all three of these things mean the same thing. So don't panic when they change how they deliver it to you a little bit. They all mean the same thing. So what's on the inside? G of x. Now remember the previous problem, we actually had numbers, like g of 3. So you can put a number in. Just follow the system. Remember, you're in algebra class. So what does this represent? A number. So we take g of x, the whole thing, which is like, okay, what is g of x? It's all of this. And we're going to rewrite that as f of g of x. All I did was I took what g of x is, because we don't have a number to plug in. So we just put the whole thing, which is right here where it belongs, and then we have to put all of this, watch this now, wherever x shows up in function f, we got to substitute it with this. That's what it's telling you to do. So we go to function f, we go, aha, there's my x. I'm going to put all of this in that spot. So I get the square root of 2x minus 5. That's the x. I just took that out, replaced it with this. Then there's the plus 7. And then you're just going to reduce it. 2x plus 2. So this is the rule for composition. Boom, f of g of x. That's how you would say it, f of g of x. Okay, that's the rule. You're just kind of plugging things in, basically. Next problem. I'm taking this one from example 6 from section 5.5. I didn't notice what page it's from, but you can find it. It's a very, very interesting problem, and it's actually going to be an application of what you've been learning on the first few, the pre-lesson, and actually so far up to this point. It's kind of cool. So they show like an advertisement on a phone, and if you were to purchase this item, you have 2 ways you can get a cheaper price. You can get $5 off your next purchase, or you can get 10% off your next purchase. Now here's the interesting thing. You could get $5 off first, then take 10% off of that, or you take 10% off the price, X, and then take $5 off that. Is there a difference? This composition of function thing is actually going to assist us in answering that. So watch this. So $5 off the next purchase, if this is my price, I'm going to call that f of x. And then if that's the original price, it's just going to be the price minus $5. We're going to call this g of x because it's different function, different program. This is 10% off the next purchase, so we take the original price, and then we subtract 0.10x. Now that actually turns into 0.9x. That's 1 minus 0.10. I could actually take that off if that helps you, and then you get 0.9x. So remember I said the problem's asking you which would be the better deal. Take the 10% off first, and then take the $5 off, or take the $5 off, and then take 10% off that. Interesting question. So how are we going to do this? Well, I'm going to figure this out by going f of g of x, and then I'm going to compare that to g of f of x. Okay, give me a second. So what is this really saying? This is saying g of x, you're going to take 10% off first, and then you're going to take $5 off that. This is saying, because f of x is take $5 off, you're going to do that first, and then you're going to take 10% off of that. See if there's a difference. So let's follow our rules. Well, g of x is 0.9x, so this turns into 0.9x. Now we got to plug that into f. So f is right here. So I need to put that in wherever x shows up, which is right here. So 0.9x minus 5. It doesn't look like much of an answer. Like, how am I supposed to answer this? Hold your hats. What's f of x? So I got to take f of x, which is x minus 5, and put it in there. So I get g of x minus 5. What do I do with that? I take all of this, and I put it in wherever x shows up into the equation defined by g. And g is right here. So I'm going to go 0.9 times x. But remember, I'm going to put all that in for x. X minus 5. I'm going to distribute this. So I get 0.9x minus 4.5. Now, you just have to do a comparison. What's the better deal? Well, we're going to subtract $5 from 90% of the cost. Here, we're going to take off $4.50 after we take 90% off. So these are kind of equal. So which one's less? This right here. So g of x is taking 10% off first, then taking $5 off. Call me a nerd. That's pretty fascinating math right there.